Okay, welcome everybody. So today I'm going to talk to you about reducing mobile data usage in your Android apps. First before we get started, what he mentioned, everything about me, you can find my website at rigoroo.co.za and on Twitter. I'm blogging a lot about Android development tutorials and just general tips, so be sure to check that out. Okay, so why did I drag you all here? Why are you here in the first place? So we should always be looking and being aware of mobile data when we're developing our apps. The mobile data, unless you've been living under a rock, is really expensive. So if you're paying out of data bundles, you're paying R2 per meg, which is a lot of money, right? If you have, say for instance, you develop an app and a user is taking photos within it and you're uploading those photos to the internet, a 14 megabyte file will take like R30 to upload. So that kind of thing you need to be aware of when you're developing your Android apps. So not only is mobile data expensive, but it's also really slow. So this is not just referring to mobile data in itself, this is also referring to ADSL lines too. So those connections are also really slow. So we need to be aware of this when we're developing, and a lot of users will most likely abandon your app if your internet is slow and their connection and your app is doing nothing. So we need to be aware of these things, and we need to start developing our apps in a way that takes these points into consideration and develops a good user experience. Okay, so the whole point of my presentation today is to try to convince you to start thinking about these kind of things when you're developing. So in the back of your mind, when you start adding new API calls, when you start adding images, that kind of thing, you need to be aware of these things and you need to start optimizing for the user, because you probably are one of the users of your own app, right? Okay, so we're going to look at 3 different areas that we can improve within our app. So the first one we're going to have a look at is the server interactions. So this is transferring data from the server to your phone. And then we're also going to have a look at images, how you can improve those. And we're going to look at your actual APK size that you are delivering to a user. Okay, so server interactions, right? This, as I mentioned, is when your device is connecting to a server and bringing down data to a user's device. Okay, so the features of your API have a very huge impact on the performance of your app. If your API is slow, if it's returning a lot of data, if it's sluggish, you need to do lots of network calls, it's going to have a big impact on your end user's experience, and they're going to actually probably rate your app really poorly on the store. Okay, so the thing that we should look at is you should always be designing with an offline first mind. So users don't care if the data that they're viewing is really old. As long as you're letting them know that you're looking at old data, they really won't mind. So for instance, what Twitter does is if you don't have internet or something like that, you're generally viewing tweets that you've loaded previously, okay? So if you start designing your apps like this in the first place, so start thinking about caching, start thinking about storing a database of data that you want to keep for offline use. So if you think about these things and design your app in this way, you'll then, doing network calls and stuff on top of it will be second, and you won't even need to worry about those kind of things because users will be not as frustrated as they're able to view old data. Okay, so the next point is that every single request that you make is counting. So if you're doing 10 requests for a certain screen, that's going to cost your user a lot of time and a lot of data. So if you have a single screen, you should be looking at maybe only 1 network call if you can. So don't do requests that aren't required right now. So if you have analytics data or something like that running in the background that's not directly involving the user, save that till they're on a Wi-Fi network. Defer it till that's not even important to them. Okay, so just some examples. First, you should aggregate your data on the backend, right? So in this case, I have a screen that has a user's profile where they have a picture and some information about repositories that they have. So instead of making 2 separate network calls, you should be combining those into one so that it's a lot faster for the user and it's a lot less wait time for them to actually have to wait for, and they have less data transfer that needs to happen, okay? So another tip that I can give is that you should be designing your API based on the usage of your app. So like in that previous slide, we would then have just 1 network call that's aggregating all this data together. And then the next piece of advice I have is to strip out unused information. So as you can see, stuff that's not displayed to the user, you should not be sending down to the client. This is stuff like created at dates or updated dates that you need in your database, maybe for logging purposes or stuff like that, but your client side will never ever display that. So you should definitely remove that kind of information. Every bit of JSON that you don't send down to the device is saving your user that little bit extra data. Okay, the next part is that you should be also GZIPing your data. So this is basically just a configuration that you would do on your server, and you can see if a content is GZIP by the content encoding. If you open up developer tools, you'll see content encoding GZIP, and if that is enabled, you're saving a lot more data in this case, right? So if there's one thing that you do here from this presentation, it's enabling GZIP on your network requests. So you can see in this case, the GitHub API, because it's GZIPed, it's saving 90% of the data that would have been transferred if it wasn't GZIPed. So this is a very good thing to do for your APIs. And but by default in Android, it's not enabled. So if you're using the default HTTP clients, it's not enabled by default. So you need to add extra code to do that. If you're using the OKHTTP clients, it is enabled. So you just need to check which client you're using and make sure it's enabled on the client side. Okay. The next thing that you should also be doing is enabling HTTP cache. So this is a header that comes down from the server that you need to add a max stale age onto it. And this indicates to the client that this request that's been made to the server will be saved in the local cache on the device for later use when I do that same request again. So for instance, if a user keeps viewing someone's profile on Twitter, for instance, you probably don't want to be making that same request every single time. So this kind of thing you would get out of the cache. So this is just a snippet of code that indicates how to do it with OKHTTP. So you would generally create a directory, a cache directory, and then set your OKHTTP client to use that cache directory. You can also do this for the default HTTP client, but OKHTTP is a much newer client that you can use on Android. Okay, and the next tip I have is when you're keeping your users' data fresh, a lot of the time people think the best way to do this is to just keep polling the server, just to say, hey, I've got this data, is there anything new? Or just give me back what you've got. And a lot of the time you're going to be wasting a user's data with this. So you're going to be polling the server and getting back the exact same data. And that is really data waste for a user. They don't care. They've seen nothing new, and you've just wasted your server's resources and your user's data. So this is not what you should be doing, right? Okay, so a way in which you can achieve this kind of keeping your user's data fresh is by using push notifications. So push notifications basically works in that you register your device on the server to say, this is me, I've got this data, please let me know when there's new data. And then as soon as your server has new data on it, it can then inform all the clients to say, here's the new data, or you should probably update your data now as there is new stuff available. So this kind of server-side polling and that kind of thing should be always done with cloud messaging. So there are a couple of options for this. There is the newest one is Firebase Cloud Messaging, which is a tool suite provided by Google, which allows you to do this kind of stuff. There's also Amazon Cloud Services. There's a lot of providers for this kind of stuff. So this is definitely a way in which you should be approaching keeping your users' data fresh. Okay, so the next thing to remember is that you should be courteous of your users. You should only do things when things that you only need and they don't. You should wait until they have Wi-Fi plugged in to be charging, that kind of thing. So if, for instance, you're doing analytics or you're doing crash reporting, stuff like that, it's not really critical for your users to send that information over their mobile data network. So you should wait until it's plugged in and they have Wi-Fi connection or an unmetered network. And then also deferring unimportant operations. So like I said, wait until later if it's not important. Okay, so this is one such class called the GCM Network Manager in Android. And this allows you to do a lot of that kind of stuff for you. So it gives you the options of scheduling periodic versus once-off tasks, doing automatic retry and back-off mechanisms, It's also aware of the network, so it's aware of when it's Wi-Fi versus 3G, and it's also aware of the device charging state. So using this GCM Network Manager, you can get all the stuff that I talked about quite easily without coding too much. It'll just notify you or run your sets of code when certain conditions are met. And it also provides persistence of the tasks across boot. So say, for instance, you were running some sort of background logging sync, and the user turns off their device, this kind of thing will handle that automatic retry for you. Okay. And then another thing to remember with server interactions is that you should probably give your user options. So for instance, in the Twitter app, they give you a sync interval option. So you can let your users decide how often they want fresh data if you can't do that server-side push notifications. Also give them options for like image quality. So this example is of Instagram offering you to use less data on mobile networks. So these kind of things puts the user back in control, and they feel like they're actually able to control how much data your app is using. So it's a really good thing to give them options and let them decide if they want high quality images or if they don't really care about their mobile data bill. Okay. And then lastly for server interactions is that you should be trying new things. So like I mentioned earlier, Google's released a new SDK, the Firebase SDKs, and this gives you real-time database synchronization, which is a really cool feature, and I believe Buddy is going to be giving a demo here next month of it. I'm not too sure though, but this is really cool. So Firebase offers you the ability to have offline information within your apps without too much effort. Like, it's really simple to do that kind of stuff. And then, like I mentioned, push messaging from the server to tell your clients that they should be updating their apps. Okay, so there's a lot of different tools that you can use to monitor the data usage within your app. So the one that I found really cool is a tool called Stetho by Facebook. So this tool, you basically add to your Android app, and it'll allow you to use the Chrome developer tools to debug your app. So it actually lists all the requests and responses and tells you how long that took, like the normal Chrome developer tools. So you don't get this out the box with Android normally, so this will allow it. There's also another thing that's not completely related to this talk, but it allows you to edit preferences that are on the device and the databases on the device. So that's a real cool part of this tool. Okay, the next one that you should be looking at is a tool called Charles Proxy. So this one proxies your network, so you can inspect your packets and edit them and send them to the server. The best part about the Charles Proxy is that you can also throttle connections. So if you want to try out a really slow network, you can say, okay, only give the user this amount of data at a certain time. You can also intercept the traffic, like I said. And if I see the next one, yeah, so this is the configuration page for the speed at which you want your requests to be delivered. So here you can emulate really slow network speeds and test your app out on these different network connection speeds. You can also specify the amount of success rate, so how reliable your network should be. So you should probably also test your app with a really bad internet connection. So like, for instance, certain network calls are failing and only certain ones are succeeding. And then you can also see how your app performs under those conditions. Okay, and then more recently, there's a new one in Android Studio called the Android Network Monitor. So this is a real-time graph that starts forming as soon as you run a debug session on your device. And as you're doing network calls on the device, it starts drawing this graph of how much data is being used over time. So this is a sort of big indication of when your device is using a network connection and when maybe it shouldn't be using network connection. So it'll pick up for you high level when you're watching it, obviously. Okay, and then the last tool that you should also be looking at is your emulator options. So the Android emulators come a long way. So you can now also emulate different network connections, and obviously there's not as many options as Charles Proxy, so you can't specify your packet loss and stuff like that, but you can emulate different network connections. So that's also an option that you should be looking into when you're testing your apps. Okay, so the next thing we're going to have a look at is your images in your app. So this is a big portion of a lot of apps where you have really rich media coming down to a user's device. I mean, there's Snapchat, there's Facebook, there's Twitter. All those are based around media, right? So a lot of the time, this is where most of your data is going to go. So this section that I'm going to cover is looking at two sections of it. So it's the data that you're downloading from the network, and it's also the images that you're packaging within your app. So those are two types of images that you should be looking at and optimizing both of them before they get to the user. Okay, so the first tip I have is don't download what your users don't see. So if you have a gigantic list of images, don't download the ones that are at the bottom. They probably won't scroll to that part, right? So don't download what they don't see. And also don't download large images for small areas. So you can have a server configured to return you sizes of images that are only required for that size of your screen. So if I have a really small image in the first picture, you'll see I can provide to my API or whatever I'm using the width that I need, and it can calculate how big the image should be. And then if I do need a bigger picture, I can just go and request it, but I can display the smaller one in the meantime while it's loading the bigger one. So you should definitely be passing the width to your server to give you back images that are only the size they need to be. Another piece of advice that I have is that you should be looking at the device pixel ratio. So for a really low-end device, like an Android low DPI device, you don't need a Retina image, right? Only your iPads that are really big will you need to actually download a really high-res image. So you should be able to tell your server, okay, this is the DPI of my device, give me a picture that is suitable for this size device. And then if I am on a Retina display, obviously download the bigger size image. And then I think the most important thing is that you shouldn't download them twice. You should always cache your images. And if you've worked on Android, there's a lot of image caching libraries that are available for you to use. So the ones such as Glide and Fresco are really good alternatives. Don't try to do this at home. You'll spend a lot of time trying to implement an image caching library. So these guys have gone through a lot of the effort that you would have gone through. So use one of those and you'll be really grateful later. Another piece of advice is you should always download lower quality on slower networks. So if you are in a really bad connection area, download a really low res image and then slowly maybe download a higher res image if the user gets into a better area or if they even care or click on the picture or something like that. Okay, so let's get into a little bit of image compression. So I was recently at Google I/O where there was a whole 40-minute talk on image compression, and it was really interesting. So the guy talked about how you can optimize your images for use on mobile, and one such example that was given was this image of the I/O logo that was packaged within the app, right? So this first image on the far side that way is the image that is 256 colors, and the size of the image is 2.12 kilobytes big, right? And it's actually only 2 colors. So by reducing the size of the number of colors of the image, the file size went down from 2.12 kilobytes to 932 bytes. So you can do miniature optimizations like this that'll have a great impact if you have a lot of assets within your app that you're saving. So that's one tip, is only reduce the number of the color space that you're using if you have an image that's only a certain amount of colors. So you can do that. And then also, if it's one other thing that I learned from that was you should always be using Save for Web when you're generating an image from Photoshop or whatever tool you're using, as this will remove excess data such as your EXIF file information like the location tag or extra information that the device won't actually need. So you should look at these images and start analyzing your app to say, okay, do these images really need to be this big? Okay, and then there's also a lot of tools that you can use for this type of compression or optimization of your image files. So if you just do a quick Google search, you'll see there's a lot. So just for PNG optimization, there's things such as ImageMagick, Zopfli PNG, True PNG. So just pick one of those and use it. Anyway, just pick one and make sure it works within your app. So if you start doing this kind of optimization by yourself, you'll see this is an image that I took of a cake I made. And the first size image that I had was 1.2 megabytes big, right? And then after doing some custom compression, this file got down to 183 kilobytes big. But then after running it through Android's build process and the output of the APK that contained it, this file size actually increased to 201 kilobytes. So this is because the default Android system is actually trying to compress your images for you, okay? So it's applying some principles and trying to reduce colors and stuff like that. So if you're doing your own image optimization and you notice that your images are actually growing after you've created your app, you need to disable the cruncher option, which is cruncher enabled equals false, and then that'll disable the Android build tool from trying to do its own optimizations. So that is obviously only if you're doing your own optimizations. Okay, so let's get on to the different image types that are supported in Android. So the first type is a vector drawable or a shape drawable. So this is your basic image outlines that you can draw, and actually it's a lot like an SVG. So you can import an SVG and transform it into a vector drawable. But there's a lot of stuff that isn't supported, such as gradients and stuff like that. So you can use vector drawables within your app, which are SVGs. Another type of image that is supported in your app is WebP, which is a format, I think, designed by Google. And this works on Android 4.1 and up. And if you're using transparent WebP, that's only supported from 4.4 and up on Android, but it is supported. The next thing, obviously, is a JPEG image, and then obviously also your PNG images are supported in Android. Okay, so how do I decide what type of image I should be using where in my app? So the first question you should be asking yourself is, can this image that I'm trying to use in my app be a vector drawable? So vector drawables typically are your things that are small outlines, shapes, things like your icons, not such big images, and obviously not too complex. So if it can be, then make it a vector drawable. And if it can't be a vector drawable, then you should look at if you support WebP. So WebP, like I said, is the Google format. And if you do, it is a lot smaller than JPEG and PNG. So you should look at using WebP if you can. And if you can't use WebP, then you should look at, do I need transparency? So obviously only PNGs have transparency. So then you would need to use a PNG. And if you don't have transparency, then you should look at is it a simple or is it a complex image? And obviously, if it's a really complex image, you'll need to use a PNG. But if it's a simple one, you would then use a JPEG. So overall, you should always ask yourself, when you have an image that you're going to put into your app, can this be a vector drawable? That's the first question that you should be asking yourself. Okay, cool. So the next section that we're going to have a look at is the bundled package size of your APK. So this is the size, this is the APK that you're delivering to the user that they have to download on their first try when they download your app from the store. So to get into optimizing this kind of thing, we need to look at what is actually bundled within the APK. So there's a lot of things that are put within your APK that you deploy. So the first set of things is your app code. So obviously your code needs to go somewhere. So this is transformed into your classes.dex file and your native code. So this is your C++ code that you've written that's running on your different architectures if you need to. The next set of things that are packaged within your APK are your resources. So this is all your PNGs, your vector drawables, that kind of thing. And then the resources.arsc file is containing references to all the resources that you've got within your dimensions files and that kind of thing. And then also packaged within your APK is your miscellaneous things such as your assets and your meta-inf information and your Android manifest. Okay, so how do we actually go about improving our app size? There's a tool that's been launched recently by Google within the Android Studio platform called the APK Analyser. So you open up an APK, and then it will tell you exactly what inside your APK is taking up the most space. So in this case, I analyzed my own personal app called Book Dash, and you can see the classes.dex file is taking up the most space. It's 64% of my app size. And then further on, you can see that the images start to take up space. So for instance, I think it's like the cover image or something like that is taking up 4% of my app. So if you can go into this fine-grained detail and you can see exactly what are the culprits of an app that's an app size that's really big. Okay, so once you've started looking at that, you can start looking at how to obviously get rid of unused code and stuff like that. So how do we remove unused code? So the first thing you should do is obviously enable ProGuard. So that's done by just saying minify enabled equals true. And then you should also be doing shrink resources. So shrink resources removes unused resources from all your libraries that are used within your app. So for instance, if you have a library that's got a whole bunch of XML files that you'd never ever touch or reference within your code, that'll be stripped out if you use shrink resources. So those two things will really decrease the size of your app that you have. Just a point to note, if you do enable ProGuard, you'll probably need to do full regression on your whole app as you'll probably broken something. So just remember that. Okay. So another thing that you can do is you can remove unused configurations. So in this example, because my app that I've made is only in English and I haven't translated it into other languages, if I add that resconfigs flag with the languages that I'm supporting, it'll remove from all the other libraries that you're referencing the strings that are translated into the other languages. So all the other languages like French, that kind of thing will be removed. And this will also reduce the size of your app. So you can see my Book Dash app went from 4 megs to 3.65 megs when I enabled that resconfig option. Okay. And then the other thing that you can do is you can do different build variants. So this is splitting your APK up into different APKs. So you can split them up by architecture. So if you have native code that you've written, x86 devices won't necessarily need the ARM code. So you can make 2 separate APKs for those different devices. And then obviously the size of them will be a lot smaller because they are split in half basically. Just to note this, you can also do it by the screen size. So if you have a low-res version, you can deploy a low-res version, a high-res version, and you can have all these different options, and then only the images for those DPI versions will be packaged with that APK. So there is that option if you do get a really large size APK. The downside of this, obviously, is that you've now got 6 or 7 APKs that you need to do testing on. So it can be, obviously, you need to decide what's more beneficial for you. Okay, cool. So that on the side is just how to do it via the Gradle code if you need to do it. Okay, so this is maybe a little bit too much, but there's a tool called ArscBlamer. So if you remember from the previous slide, I talked about the resources.arsc file. So that file can get really big if you start adding a lot of different configurations. So if you have a string or a Boolean value for if it's a tablet and you don't have that value for other different configurations, this resources.arsc file gets really big from those kind of changes that you do. So ArscBlamer, it's a command line tool that you can run on your Android app, and it will give you out a useful CSV file that you can extract information from and decide what is taking up a lot of space within your app. So if you have strings or dimensions that are defined for a lot of values, you can look at removing certain things and optimizing those kind of things. Obviously, this is very minute optimization, and this is only if you really want to get into the real crux of where your app is going wrong. Okay, so that's a lot of tools and a lot of talk. So to sum it all up for you guys, there's 3 things you need to remember, is that every request you make is counting, and you should probably be doing less than what you already are. You need to start optimizing your image usage, so use vector drawables if you can, apply compression, and then reduce the size of your app that you deliver to your users. So optimize your images, remove unused code, and ProGuard your code. And yeah, that's it. Thank you. There's some links. Any questions? Yeah?
Just on the part of battery saving, tips do you have for client-side processing? Like you find that the app that person made now kills the battery or is also slow. So
Yeah.
what would you advise with regard to that?
So there is another tool called Battery Historian that you can use to analyze a device's battery usage. I did do a talk a while ago on that, that's online that you can watch. But basically, what you can do is analyze and see, do I have services running for a long period of time? So it's basically, you have to take it case by case, right? You need to look at it as an overall thing to say, am I running services in the background that shouldn't actually be running? Am I doing unimportant things? Stuff like turning on the GPS for an hour when it's not needed. Like things like that you're going to have to look at on a case-by-case basis. So definitely if you optimize your usage of server-side calls, your API calls, you are going to make a positive impact to the battery usage of your app. I mean, like obviously it won't be a great amount of improvement, but it will improve the usage if you do these kind of things. Hope I answered. Anyone else? Yeah.
You mentioned Firebase in your talk. I looked at Firebase quite a while ago, but the pricing was like insanely expensive. But their logo looks a bit different, and I think they were acquired by Google or something like that. Like,
Yeah.
what's the story there?
So Firebase recently, it was acquired by Google, I think last year sometime. And when it was acquired by them, it was just a real-time database. So now at the past Google I/O, they've actually expanded Firebase into a set of products. So it's not just your real-time database. It's now push notifications, storage. It's basically like a whole, everything you would need to develop a mobile app. So also analytics, mobile-specific analytics, crash reports. So it's a lot more than just now a real-time database. And I think they also have a lot of free plan. They have a free plan now as well. So I'm not too sure on the costing above the free plan, but I've only used the free plan so far. So yeah. Cool. Anybody else?
You talked about ProGuard and having to run regression tests. What happened? What's happening with ProGuard?
So when you run ProGuard, it strips out or it changes your class names into obfuscated class names, right? So for instance, if you have let me think about an example. So the retrofit stuff, right? If they have, you have annotations on your stuff, so you have like a get annotation or stuff like that. As soon as you try to do like JSON parsing within that stuff, and it's changed all those names, your code will actually break when you try to run those kind of things. So it's changed the code, but your app won't work anymore. So there's a lot of things like that, a lot of even the Android framework stuff. So it'll ProGuard that, but then your app won't work anymore. So yeah. Anything else? I've spent a good few days doing that. I mean, it depends on the size of your app, right? And if you're doing it incrementally. So if you do a build that's only got a small function and you make sure ProGuard works with that, then obviously you've done like a few ProGuard rules and you've only spent like an hour trying to fix the ProGuard problems. And then like you do another build. But if you go like, okay, develop everything and then at the end you do ProGuard, you might spend a lot more time. I mean, it is worth it though, because you do also get the obfuscation. So then people can't see what your code is actually doing. Cool. Any other questions? No. Cool. Thanks, guys.